Bismillahirrahmanirrahim. Dear students, in the previous lecture, we were discussing the diaphragm cell and its working, where we have discussed that the diaphragm cell consists of two electrodes, anode and cathode. Cathode is formed of cast iron and anode is formed of graphite, and these two electrodes are separated through asbestos diaphragm. And the purpose of that asbestos diaphragm is that will permit the ions to pass through it, but it will not permit the products to pass through it. Now, we are going to discuss some advantages and disadvantages of diaphragm cell. And the first point is that the electrodes can be placed close together, and this permits compactness of diaphragm cell of low electrical resistance. They easily become congested with use and therefore must be replaced regularly. Diaphragms permits flow of brine from anode to cathode, and this reduces greatly on side reaction like formation of sodium hypochlorite. As we are discussing the introduction of chloralkali process, in that process we have said that if we will not remove chlorine, then it will react with our product and will form sodium oxychloride or sodium hypochlorite. So if you will use diaphragm cell, that side reaction will not occur, and this is the main advantage of diaphragm cell. And the next point is diaphragm cells with metal cathodes like titanium coated with rare orthoxides rarely develop congested diaphragms and do not require regular replacement. This reduces on operating costs. In second point, we have said that the electrodes become congested with the use. So there is need of regular replacement. How can we get rid of that regular replacement? If we will use electrodes of titanium which are coated with rare orthoxides metals, then they will not become congested easily, and we will get rid of that regular replacement. So these are some points which we have discussed in this slide. The first one is that by placing electrodes together, we can permit the compactness of cell. And the second point is that the electrodes become easily congested with the passage of time or with the usage. And third point is that it will not permit the chlorine to react with sodium hydroxide to form sodium hypochlorite. And at the end, we have discussed that how can we get rid of that regular replacement? We can get rid of that regular replacement by using electrodes coated with rare orthoxide metals. The next point is the release of asbestos to the environment is a major anticipated problem of diaphragm cell. Diaphragms made of corrosion-resistant plastics are a proposed solution to asbestos pollution. He said that in this point, as you use diaphragm cell in which diaphragm is made of asbestos, which will release asbestos as you use, and that will produce asbestos pollution. You can get rid of that asbestos pollution by using corrosion resistant plastics, electrodes or diaphragms to overcome that asbestos pollution. And the next point is, a major advantage is that diaphragm cell can operate on dilute 20% reasonably impure brine. Such brine produce dilute sodium hydroxide contaminated with sodium chloride. Concentration to about 50% are achieved by use of multi-effect evaporators. Studies have shown that nearly 2600 kg of water must be evaporated to obtain 1 ton of 50% caustic soda. Diaphragm cell technology is still in use, but the use of asbestos in this cell is causing new plants to turn to the newer ion exchange or membrane technology. Dear students, in this we have discussed 3 points. First point is that asbestos reagent produce asbestos pollution, and you can overcome this asbestos pollution by using corrosion resistant plastics diaphragms. And in the next point he said that diaphragm cell operate in a very dilute form solution. And in the third one he said that diaphragm cell technology by using asbestos diaphragm now is replaced by the membrane cell process or membrane cells. So these are the advantages and disadvantages of diaphragm cells, which we have discussed. So far, dear students, we have discussed mercury cell process and diaphragm cell process. In those processes, we have discussed that in diaphragm cell, we will not use diaphragm cell because it uses more energy as compared to diaphragm cell and membrane cell. And as we have discussed diaphragm cell, we have said that there is the disadvantage of diaphragm cell usage is that it will produce asbestos pollution. So what cell is remaining now? The most beneficent and most important method is now membrane cell process, which is very important as compared to other two processes, because other two processes have disadvantages. Now the introduction of membrane cell processes. Improved design of membrane cell and cheaper purification have increased the economics of new membrane cell process. In this process, rather than using a diaphragm, semi-permeable membrane made of plastic sheets is used to separate the anode and cathode compartments. The plastic sheets are porous and chemically active to allow the sodium ions to pass through but reject the hydroxyl ion. Dear students, as we have discussed that in diaphragm cell, there is the separation between the two electrodes by asbestos diaphragm. Here in membrane cell process, that diaphragm cell is replaced by the semi-permeable membrane, which is made of plastic sheets. That semi-permeable membrane or that plastic sheets are chemically active, which will allow the sodium ion to pass through it, but it will not allow the sodium hydroxide or hydroxyl ions to pass through it. Here we have discussed two very important points. The first one is that in the membrane cell, we have used semi-permeable membrane which is formed of plastic sheets, one point. And the second point is that in the membrane cell, that plastic sheets which are being used as a semi-permeable membrane are active, which will allow the sodium ion to pass through it, but it will not allow the hydroxyl ion to pass through it, or it will reject the hydroxyl ion. Dear students, we have said that in the previous slide, the semi-permeable membrane is formed of plastic sheets. Now, we are going to discuss some examples of semi-permeable membrane. An example of membrane material is perfluorosulfonic acid polymer. The membranes exclude hydroxyl ion and chloride ion from the anode chamber, thereby making the product free from the salt contamination experienced in the diaphragm cell. Students, in this point he said that membrane will exclude or will not allow the hydroxyl ion or chloride ion to pass through it from the anode chamber, because chlorine and hydroxyl ion are not passing through it. So as a result, the side products, salts, will not form as in the diaphragm cell were formed. So if the salts are not formed, it means the membrane cell will give you more pure product as compared to diaphragm cell. The membrane cell use more concentrated brine solution and produce purer and more concentrated sodium hydroxide, which requires less evaporation during concentration. In diaphragm cell, we have said that diaphragm cell will work in dilute solution form, but the membrane cell will use concentrated solution and will form concentrated product and purer product, which need less evaporation as compared to diaphragm cell, because in diaphragm cell we have used dilute solution which produce impure product and need more amount of evaporation to get concentrated product. But in the membrane cell, it will use more purer and concentrated solution, which will produce more purer and more concentrated product, which will need less evaporation as compared to diaphragm cell. Dear students, so far we have discussed the working of membrane cell. In that cell, we have discussed that there are two electrodes, anode and cathode, and these electrodes are separated by semi-permeable membrane, which is formed by plastic sheets, and those plastic sheets are chemically active, which will not allow the chloride ion and hydroxyl ion pass through it from the anode chamber, because these ions are not passed through it toward the anode chamber, due to which the product will be more purer, because there is no contamination of salt at all, which was noted in diaphragm cell. So because there is no contamination of salt, now our product will be more concentrated and more purer, and require less amount of evaporation to be more concentrated. So here is the first point in the representation of diaphragm cell, mercury cell membrane cell or chloralkali membrane cell. Brine is pumped into the anode compartment and only sodium ion pass into the cathode compartment, which contain pure water. Thus, the caustic soda produced has very little salt contamination. In this point, he said that as brine is pumped to the anode compartment, now electric current will pass through it. Those semi-permeable membrane or plastic sheets now will allow only sodium ion to pass through it and will not permit the other ions to pass through it, due to which that sodium is converted into caustic soda or sodium hydroxide that will have very little amount of contamination of salt. Otherwise, that product is very pure and very concentrated, which needs less amount of evaporation to get concentrated product. So till now, students, we have discussed three methods of preparation of sodium hydroxide. First one was diaphragm cell process, second one was mercury cell process, and the third one is membrane cell process. We have discussed the advantages and disadvantages of these three processes, and we also discussed that why we prefer diaphragm cell over mercury cell process and why we have preferred membrane cell over both of rest of these two processes. Dear students, till now we have discussed three processes by which you can prepare sodium hydroxide. The first one was mercury cell process, the second one was diaphragm cell process, and the third one was membrane cell process. In all of these cell processes, we have seen that there is the electrolysis of brine, then there is the production of sodium hydroxide and chlorine and hydrogen. We have seen different cell process in diaphragm cell. That diaphragm will not permit the charges, will permit the charges but not permit the product. Similarly, we have seen in the membrane cell process, there is the membrane which only allow the sodium ion to pass through it toward the cathode chamber, but not allow the different ion, hydroxyl ion or chloride ion, to pass through it. After the concept of that electrolysis and the production of sodium hydroxide and chlorine, now we are going to discuss the flow sheet diagram of chloralkali process. In this process, the first of all, we have salt. Now we will prepare its solution. That solution contain, it may be contain calcium salt, magnesium salt, sulfates. Now these impurities are removed by filtering the brine solution. After the filtration, that brine solution is now passed through the chamber where its pH is adjusted. Now when pH is adjusted, there is electrolysis. As electrolysis is done, sodium hydroxide is produced, hydrogen is produced, and chlorine is produced. Sodium hydroxide is cooled down and separated. Now what will be happen to the chlorine and hydrogen? The hydrogen will be separated, cooled down, and used for the different purposes. Similarly, the chlorine is separated, cooled down, dried, compressed and used for the different purposes. So students, this was the explanation of flow sheet diagram of chloralkali process through membrane cell process. Dear students, after the discussion of sodium hydroxide production, now we are going to discuss its chemical properties. Here we will see that how sodium hydroxide will react with the acids, acid oxides, metals, metal oxides and precipitants. So the first of all, reaction of sodium hydroxide with the acids. Sodium hydroxide react with protic acids to produce water and the corresponding salts. For example, when sodium hydroxide react with hydrochloric acid, sodium chloride is formed. Dear students, in this point, he said that when sodium hydroxide react with protic acid, an acid in which hydrogen ion is connected with more electronegative atom is known as protic acid. When sodium hydroxide react with protic acid, it will produce water and salt. Dear students, this is the kind of reaction which is known as neutralization reaction, in which acid and base react with each other and form salt and water. Here in the figure you can see that sodium hydroxide is reacting with hydrogen chloride and forming NaCl, which is salt and water. In general, such reactions are represented by one simple net ionic equation in which hydroxyl ion from sodium hydroxide, hydrogen ion from hydrogen chloride will react with each other and form water. Dear students, in the figure, in the second reaction, he said that the acid-base reaction or neutralization reaction, generally you can represent that by simple equation by writing by the reaction of hydroxyl ion from sodium hydroxide and hydrogen ion from hydrogen chloride. When they will react with each other, they will form water. And the next one is this type of reaction with a strong acid releases heat and hence is exothermic. As you know that the reactions which releases heat or the reactions during which the heat is released are known as exothermic reactions. Such acid-base reactions can be used for titrations. However, sodium hydroxide is not used as primary standard because it is hygroscopic and absorbs carbon dioxide from air. So, students, here we have discussed the reaction of sodium hydroxide with acid, and we have said that this type of reaction is known as neutralization reaction, in which when sodium hydroxide will react with protic acid will form salt and water, and these type of reactions are exothermic reactions in which the heat is released toward the toward the surrounding. Now, the reaction of sodium hydroxide with acidic oxides. Earlier, we have discussed the reaction of sodium hydroxides with acids in which salt and water were formed. Now, the reaction of sodium hydroxide with acidic oxides. Sodium hydroxide also react with acidic oxides such as sulfur oxide, sulfur dioxide. Sodium hydroxide will react with acidic oxides such as sulfur dioxide, which is an acidic oxide. Such reactions are often used to scrub harmful acidic gases like sulfur dioxide and hydrogen sulfide produced in the burning of coal, thus prevent their release into atmosphere. For example, in the figure, sodium hydroxide is reacting with sulfur dioxide and forming sodium sulfide and water. What he said in this reaction, he said that sodium hydroxide react with acid oxides such as sulfur dioxide or hydrogen sulfide. This type of reaction will use to scrub the harmful acidic gases like sulfur dioxide and hydrogen sulfide. How it remove this type of reaction, remove these kind of gases? Dear students, because sodium hydroxide react with hydrogen sulfide and sulfur dioxide both to form the different product and converting it to different products which are not harmful to our bodies or plants. So due to this reason, we said that this kind of reaction is used to scrub the harmful gases like sulfur dioxide and hydrogen sulfide. And in the figure, you have seen that sodium hydroxide react with sulfur dioxide and form sodium sulfide. The next reaction is reaction with metals and metal oxides. Till now, we have discussed the reaction of sodium hydroxide with acids and acid oxide. Now, the next reactions are reaction with metal and metal oxides. The first point is glass reacts slowly with aqueous sodium hydroxide solution at ambient temperatures to form soluble silicates. Because of this, glass joints and stopcocks exposed to sodium hydroxide have a tendency to freeze. Flask and glass line chemicals reactors are damaged by long exposure to hard sodium hydroxide, which also frosts the glass. Sodium hydroxide does not attack iron at room temperature since iron does not have amphoteric properties. It means it only dissolves in acid, not base. The next point is, nevertheless, at high temperature, iron can react endothermically with sodium hydroxide to form iron 3 oxides, sodium metals, and hydrogen gas. This is due to the lower enthalpy of formation of iron 3 oxide, which is minus 824.2 kilojoule per mole compared to sodium hydroxide, which is minus 500 kilojoule per mole. Thus, the reaction is thermodynamically favorable, although it is endothermic nature indicate non-spontaneity. Dear students, here we have discussed 2 points. First one is that sodium hydroxide damage the glass apparatus when it is exposed to the hard sodium hydroxide. And then we have said in that point that iron does not react with sodium hydroxide at room temperature. And in second point, we have said that iron can react with sodium hydroxide at ambient at high temperature of more than 500 degrees centigrade and will form iron 3 oxides. As we have said that sodium hydroxide will not react with iron because iron is not amphoteric. So, at room temperature, it will not react with sodium hydroxide. It will react with sodium hydroxide at temperature more than 500 degrees centigrade. Now, what will happen to it? Consider the following reaction between molten sodium hydroxide and finely divided iron fillings. A few transition metals, however, may react vigorously with sodium hydroxide. Dear students, in the figure you can see that this is the reaction between the finely divided iron fillings and molten sodium hydroxide, which produce iron oxide, sodium and hydrogen. He also said that some transition metals can also react with sodium hydroxide vigorously. So, dear students, in the reaction of sodium hydroxide with metal and metal oxides, we have discussed that the iron sodium hydroxide will damage the glasswares, and in that point we have discussed that sodium hydroxide will not react with iron at room temperature. And then we have said that sodium hydroxide will react with iron above 500 degrees centigrade and will form iron 3 oxides. And here in this figure we have seen that there is the reaction of finely divided iron with the molten sodium hydroxide, and it produced iron 3 oxide along with sodium and hydrogen. So these are the reactions of sodium hydroxide with metals and metal oxides. Now the last one reaction is reaction of sodium hydroxide with precipitants. Unlike sodium hydroxide, which is soluble, the hydroxide of most transition metals are insoluble, and therefore sodium hydroxide can be used to precipitate transition metal hydroxides. The following colors are observed: blue for copper, green for iron 2 oxide, yellow or brown for iron 3 oxide. Zinc and lead salts dissolve in excess sodium hydroxide to give a clear solution of sodium zinc oxide or sodium lead oxide. What it means, he said that like sodium hydroxide, the most of transition metal hydroxides are insoluble, and sodium hydroxide is soluble. Now, sodium hydroxide can be used to precipitate transition metal hydroxide. When it will be precipitated, then different colors will be obtained. Now, if it will give you blue color, then it is copper. If it will give you green color, then it is iron 2 oxides, or the compounds in which there is the oxidation state of iron is 2. If it will give you yellowish or brown color, then there is iron 3 compounds. Zinc and lead salts dissolve the excessive sodium hydroxide and give clear solution. And the last point is aluminum hydroxide is used as gelatinous flocculant to filter out particulate matter in water treatment. Aluminum hydroxide is prepared at treatment plant from aluminum sulfate by reacting it with sodium hydroxide or bicarbonate. Now, dear students, there is the reaction of aluminum sulfate with sodium hydroxide. You can see that when aluminum sulfate react with sodium hydroxide, there is the production of aluminum hydroxide and sodium sulfate. When aluminum sulfate react with sodium bicarbonate, it will give you aluminum hydroxide, sodium sulfate along with carbon dioxide. So dear students, these are the reactions of sodium hydroxides with acids, with acidic oxides, with metals and metal oxide, and at the end there is the reaction of sodium hydroxide with precipitants.